Today, we are going to visit one of the most iconic observatories in the world, the Very Large Array in New Mexico. This incredible facility has been at the forefront of astronomical research since its inception, helping scientists make groundbreaking discoveries about the universe. You may be more familiar with the VLA than you think. It has been featured in several books and feature films. Here is a partial list. Films: 2010, Independence Day, The Arrival, Contact, Terminator Salvation, Transformers, Dark of the Moon, Cosmos, A Personal Voyage. Books: Contact, a 1985 novel from which the movie Contact is based. The comic book G.I. Joe, America's Elite. The New Jersey rock band Bon Jovi shot their music video every day at the VLA. And an antenna dish can be seen on the cover of the album Bounce. Also, the cover for the Dire Straits album titled On the Night features the VLA. Now that you realize that the VLA isn't totally unfamiliar to you, let's go explore it. As we drove west along Old Highway 60, we began to get a glimpse of the array of antennas that make up the VLA. Our excitement grew as we got closer. We finally reached the road to the visitor center area. We parked in the parking lot and entered the visitor center. Inside, we were greeted with this sign. There were no staff that we could find in the building. We were puzzled at first, but then figured out that you have to use a self-service kiosk to pay your entrance fees. This appears to be on the honor system. We paid our fees and entered the display areas. Here are the entrance fees. There are a number of interesting exhibits within the visitor center. Plus, a movie called Beyond the Visible, the story of the Very Large Array, and narrated by Jodie Foster, usually plays on a continuous loop in the visitor center. Here is a quick sampling of some of the indoor exhibits. Once you have viewed all the indoor exhibits, it is time to go outside and walk the grounds. But first, you should read this sign. The green line illustrates the only places you are allowed to go as you conduct your self-guided tour. Since this is the desert, you really want to pay attention to this sign. There are a number of interesting exhibits outside, including this one that explains how parabolic dishes work. Grab a partner. One of you will speak softly into one dish while the other listens at the focus, the little black ball, of the other dish. Can you hear your partner's whisper? These little dishes bounce your partner's faint sound waves from several feet away and focuses them into your ear. Similarly, each 82-foot wide dish of the VLA bounces very faint radio waves from very far out in space and focuses them on its receivers. After viewing the smaller outside exhibits, it was time for the big ones. How big, you ask? This sign explains just how big the big ones are. You can fit 2 full-size school buses end to end inside each dish. That's 82 feet across, or about 25 meters. There are 27 dishes spread out in a Y shape. The north arm is 11 miles long, and the other 2 are 13 miles long. The antennas are moved along these sets of railroad tracks to get them into very precise positions. The VLA is an interferometer, which means that the data from each antenna can be combined electronically so that the array effectively functions as one giant antenna. The Y-shaped array can be arranged into 4 different configurations: A, B, C, or D, depending on the distance between the antennas. In the A configuration, the antennas are placed very wide apart, making the array effectively a radio telescope of about 22 miles wide. The antennas are moved along a fleet of special-purpose transporters. They each weigh 100 tons empty and 335 tons with an antenna loaded on it. Top speed is about 4 miles an hour. In total, there are 82 miles of these tracks made from recycled railroad tracks. This might be a good time to tell you about the VLA's construction timeline. August 1972, VLA is approved by Congress. April 1973, construction begins on the VLA. September 22, 1975, first antenna is put in place. February 18, 1976, the first interferometric observations are made. 1980, formal dedication of the VLA. Each antenna produces huge amounts of data. So how does the telescope gather that data? The radio waves are focused into this feed horn and then travel down into the electronics, which amplify them several million times. These amplified signals are then converted to intermediate frequencies and passed on to the computers via underground waveguides. The VLA requires one of mankind's fastest supercomputers, the WIDAR correlator. It performs 16 quadrillion calculations every second on data streaming in from the 27 antennas. How fast is that? Well, if every person on planet Earth did one math calculation every second on a calculator, it would take all 6 billion of us a month to collect what WIDAR processes in just 1 second. So what does the VLA do with all that data? The VLA has had a major impact on nearly every branch of astronomy, with over 5,000 astronomers from around the world using it for more than 14,000 different observation projects. The results of this research have been published in scientific journals and textbooks, and more than 500 PhD degrees have been awarded based on research done with the VLA. This fits right in with the mission statement of the National Radio Observatory. The National Radio Observatory enables forefront research into the universe at radio wavelengths. In partnership with the scientific community, they A. provide world-leading telescopes, instruments, and expertise. B. They train the next generation of scientists and engineers. C. They promote astronomy to foster a more scientifically literate society. We visited on a weekday, but on the first and third Saturday of each month, volunteers conduct behind-the-scenes tours of the facility at 10 a.m., 12 noon, and 2 p.m. I really wish we could have been there for one of these tours. No reservations are required. Just show up 30 minutes ahead of time. There are actually 28 antennas currently at the VLA. 27 of them are in the field, and one is a spare and is located in this repair facility. However, big things are about to happen at the VLA. The Next Generation Very Large Array, or NGVLA, is a radio telescope that will be designed and developed by the National Astronomy Observatory and the scientific and technical communities. The NGVLA will have 244 antennas that are each 18 meters in diameter and an additional 19 antennas that are each 6 meters in diameter. The NGVLA will also have the shortest baselines, which are the largest structures visible in the sky. Once approved, construction on the NGVLA could begin as soon as 2026. With projected early scientific observations starting in 2029 and full scientific operations by 2035. 。
The idea for a next generation VLA was inspired by the VLA itself and the Atacama Large Millimeter Array in northern Chile. The NRAO, in conjunction with our science community, envisioned the NGVLA as a new large radio interferometer that will open up new discovery space in astronomy. Our idea for this is an instrument that is 10 times the sensitivity and 10 times the spatial resolution of the VLA or ALMA.
I am very excited about the data that will come from a next generation VLA. It will be exquisite in detail, the sensitivity will be unparalleled, and the opportunities that it will open up in many different science areas is really one of the things that excites me most, that this is a very open facility that anyone who has a great science idea can propose for and use, and its flexibility and its versatility enable many more science questions to be addressed than what we can think of right now.
The next generation VLA has been designed to accomplish 5 main science goals: unveiling solar system analogs, probing the initial conditions for life through astrochemistry, charting the assembly, structure, and evolution of galaxies over cosmic time, perform fundamental tests of gravity, and understand the evolution of black holes.
One of the things I work on is measuring the distance to stars and star-forming regions, and measuring their distance and how they move within the star-forming regions. Currently, we can only do 20, maybe up to 100 stars in these star-forming regions. The star-forming regions contain thousands, tens of thousands, hundreds of thousands of stars. With the next generation VLA, we'll be able to study 10,000 stars in these star-forming regions, which will help us give definitive answers to major questions in star formation.
The NGVLA will be a superb black hole hunting machine, the ultimate black hole hunting machine. The NGVLA's high-resolution imaging, combined with its fast mapping capabilities, will enable it to search for radio transients associated with gravitational wave sources, neutrino transients, and optical observatory transients, and identify those with black holes that are involved in violent merger events.
You may be wondering why the VLA is located way out here in the middle of the New Mexico desert. 2 reasons. First, radio astronomers are in a constant battle against radio pollution. Radio and television stations, two-way radios, and wireless internet send out strong radio waves to carry their broadcasts. Even cell phone signals can blind the VLA's sensitive radio eyes. Towns and cities produce such strong radio signals that they appear as glaring headlights to a radio telescope. Second, water vapor in the atmosphere can reduce the cosmic signals that reach us from space. For these reasons, the VLA needs to be somewhere that is radio quiet and dry. The VLA sits on the plains of San Agustin, a dried-up bed of an ancient lake. The plains are flat for 55 miles. A perfect site for the railroad tracks that carry the giant movable antennas. The Very Large Array's influence extends far beyond the realm of astronomy. It has shaped our culture, stirred our imagination, and inspired countless individuals to look up at the night sky in wonder. It's a testament to what we can achieve when we combine our talents, our curiosity, and our dreams. Thank you for joining me on this extraordinary exploration of the Very Large Array. The journey through the cosmos is an endless one, filled with mysteries waiting to be unraveled, and the VLA is one of our most powerful tools in this quest. As usual, please like, subscribe, and ring the bell so that you will be notified of our next adventure. And if you like, you can buy us a cup of coffee by clicking on the link in the description. Thank you so much for visiting, and we'll see you next time.